Hey Geometry, we're moving on with what we need to learn about sine, cosine, and tangent. Sine is abbreviated SIN, cosine is abbreviated COS, and tangent is abbreviated, I don't know why I made that T so funny, TAN. Cool? Okay, to get into things, identify the opposite and hypotenuse ratios for angle A and angle B. First of all, just like last lesson, I'll always draw an angle across from angle C, which means this is the hypotenuse. That's the 90-degree angle, which is also the biggest angle. Okay, so first let's look at angle A. Here we have adjacent. So for angle A, we're doing opposite. I don't know why goodness, we're doing awesome already. Opposite for for angle A is 12. I should just start over. I know I should. And hypotenuse, as we just said, is 13. And then angle B, we're going to do opposite over hypotenuse. Identify the adjacent hypotenuse ratios for angle A and angle B. Now we have adjacent to angle A is 5, hypotenuse is 13, and angle B, adjacent to angle B is 12, and hypotenuse is 13. Describe the relationship between the ratios for angle A and angle B. If we look at it, change colors, hold on. We have the opposite over hypotenuse ratios for angle A is equal to the adjacent over hypotenuse ratio for angle B. Crazy, huh? And then the opposite over hypotenuse ratio for angle B is equal to the adjacent and hypotenuse ratio for angle A. Okay, see how they're sort of connected in opposite ways, or in contradicting ways, or I don't know, they're connected. And let's discuss why. Okay, I made myself a note here because I wanted to make sure I hit it within the lesson. This is sort of an aside. It's like, let's make sure that we all understand this before we move on. If I write sine x or cosine x or even tangent x, I'm not writing sine times x. Okay, that's not correct. This is not cosine times x. Okay, it's really important that we all understand that. Because that, if I ever get something like sine x over x, those aren't going to cancel out. Okay, that's not possible. And if I ever want to square sine x, I'd have to square the whole thing. Okay, that is true. Okay, this is false. Also not possible. That's not possible. And even if we have sine x squared over x, you can't cancel those out. Okay? Basically, if we stick to this rule, that sine times x is the same as sine x, that's not true. And we'll explain to you why here now. Okay, just more information on what we're doing. In geometry, sine, cosine, and tangent are thought of as ratios. Ratios of triangles. Okay, they're not functions. We don't put these on a number line. I don't know, it's just that they're ratios of a triangle. So if I have a triangle, they're just ratios of two sides of a triangle, comparing two sides. So for instance, the abbreviation sine A or sine theta, it's just an abbreviation. For the sine of angle A or the sine of an angle, the sine of an angle measure, which is like theta. Okay, theta is a name that we would give an angle measure as time goes on. Parentheses are used more for grouping and clarity than as symbols used to represent a function. So even if we do this, it's just clarity. Okay, it's not to group anything, it's just to clarify. All right. Nope. So to continue on with our discussion on trigonometric ratios, sine, cosine, and tangent, as we've said, these represent ratios of the sides of a triangle. It's a lot easier when we're talking about triangles to use these abbreviations as ratios than to always write, I don't know, A colon B, C colon A, angle A, we're referring to this, angle B, we're referring to this. It's just jumbled up. So mathematicians long time ago came up with the trigonometric ratios so that all mathematicians and all people that are going to use this for geometry are using the same language. And actually, the sine, cosine, and tangent ratios, that's something that all of us can use as we are living through life, which we'll come to some examples in the next few lessons that show you how you can use this in the real world. But that's why we've made up these ratios. So if we are looking at sine A, that's sine of angle A, equals opposite over hypotenuse. So if we're looking at angle A, first of all, let's say there's our hypotenuse. Opposite of angle A is going to be over here, and we know what the hypotenuse is. So I can write this out as opposite equals BC, hypotenuse is AB. So if we had values there, we would have values there. Just like if I did sine of angle B, that is also opposite over hypotenuse. But opposite of angle B is AC over hypotenuse is AB. Okay, cosine A, cosine, the ratio for cosine is adjacent over hypotenuse. Adjacent to angle A is AC. Hypotenuse is still AB. And then if we did cosine of angle B, it's still adjacent over hypotenuse. It's just adjacent to angle B. Next to angle B is BC. And hypotenuse is still AB. Notice my hypotenuse is the same every time I talk about the hypotenuse. And then tangent A is opposite over adjacent. Tangent B is also opposite over adjacent. Opposite of A is BC. Adjacent to A is AC. And then opposite of B is AC. Adjacent of B is BC. we'll go over this in the future, but tangent of anything is sine over cosine. So if we looked at tangent of A, I would have sine of A over cosine of A. So BC over AB over, let's see, cosine of A, AC over AB. AC over AB. The AB's cancel out and you're left with BC over AC. Right there. But we'll do that again. I just wanted to sort of briefly introduce it to you right now. Okay, one more thing I want to sort of introduce you to just briefly. If we have sine of a value, it's opposite over hypotenuse. The inverse of that is called cosecant, which is abbreviated cosecant. It's the inverse, so I flip it. We also have, we just said cosine equals adjacent over hypotenuse. We have an inverse of that too called secant. The abbreviation is SEC, and it is the inverse. Then of course, opposite over adjacent. The inverse of that is called cotangent, which is abbreviated, and it's just the flip. Okay, so you might want to sketch that down. I have one more thing. How I've always remembered, I guess since I was a bit younger, how to memorize sine, cosine, and tangent. Just write it down again. Sine is opposite over hypotenuse. Cosine, we'll say sine of x. Adjacent over hypotenuse. And tangent equals opposite over adjacent. Sort of a thing that you can remember is SOHCAHTOA. Okay, I'm sure we can come up with a chant or something, but if you just remember SOHCAHTOA, all that says is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. SOHCAHTOA. I know, it doesn't mean anything, but it's how I've always remembered SOHCAHTOA. Cool? All right, let's move on. Okay, exercises 4 through 9. In triangle PQR, the measure of angle P is 53.2 and the measure of angle Q is 36.8. Complete the following table. Okay, so we can say that sine of 53.2, oh, it's going to be impossible for me to write into that little table. So we're just going to write outside of it. All right, so A, sine of 53.2 equals, remember, SOHCAHTOA. Let me fix that. Okay. So sine of 53.2 is opposite over hypotenuse. And here's my hypotenuse. Opposite of 53.2 is 4. And hypotenuse. B, I've got sine of 36.8 equals opposite of 36.8 is 3, and my hypotenuse is not changed. C, cosine of 53.2 equals adjacent over hypotenuse. cosine of 36.8 equals adjacent over hypotenuse. So adjacent to the 36.8 is a 4. And then part E, tangent 53.2 is opposite over adjacent. So opposite over adjacent. And then part F, tangent of 36.8 is adjacent, sorry, opposite over adjacent. Opposite over adjacent. Cool. In the triangle below, the measure of angle A is given, the measure of angle B is given. Complete the following table. Okay, A, we have sine of 33.7. Sorry, we'll go SOHCAHTOA. There's my hypotenuse. This might take a little more space because we have to rationalize our fractions. Opposite over hypotenuse, 2 over the square root of 13. I need to rationalize that. So I multiply it by the denominator, and I get 2 square roots of 13 over the square root of 169, which is 13. So 2 square roots of 13 over 13. B, sine of 56.3. Sine is opposite over hypotenuse. So 3 over the square root of 13. I need to multiply by the square root of 13. That equals 3 square roots of 13 on the top over the square root of 169, which is 13 on the bottom. So we have 3 square roots of 13 over 13. Part C, cosine 33.7 equals, cosine is adjacent over hypotenuse. 3 over the square root of 13, which we've already rationalized. 3 square roots of 13 over 13. D, cosine 56.3 is, cosine is adjacent over hypotenuse. Adjacent over hypotenuse, 2 over the square root of 13, which we've also already rationalized. And then F. Need to do some erasing up here, a little messy for my liking. Okay. Tangent of 33.7, TOA, opposite over adjacent. So we have opposite over adjacent, 2 over 3. And then, sorry, that was E. F, tangent of 56.3. I need adjacent, sorry, opposite over adjacent, TOA. Opposite over adjacent, 3 over 2. Cool. Okay, in the triangle below, let E be the measure of angle E and D be the measure of angle D. Complete the following table. I'm going to go ahead and do this, and you can check out the answer when you go ahead and finish this one on your own too. Okay, I'm going to push pause and work through it. Be right back. Alright, there you go. Check out the answers. Star it and ask me tomorrow if you have any questions. That should make sense. Okay, try another one. I'm going to go ahead and push pause though and put the answers in. There you go, number 7. I believe we have one more, something like this. Tammer did not finish completing the table below for a diagram similar to the previous problems. that the teacher had on the board where P was the measure of angle P and Q was the measure of angle Q. Use any patterns you notice from exercises 1 through 4 to complete the table for Tamer. Tamer? I don't know. I'm going to draw a blank triangle. Let's see. We know the hypotenuse is going to be 157, and it doesn't matter. I'm going to label that one P and that one Q. So sine, cosine, tangent. Sine is opposite over hypotenuse, so if we're going for P, I have opposite over hypotenuse. So this right here should be 11. And then if I look at cosine P, that's adjacent over hypotenuse, so this should be 6. Let's just check. Tangent P is 11 over 6, which is opposite over adjacent, 11 over 6. Cool. So let's do Q. Sine of Q. Sine is opposite over hypotenuse, so 6 over square root of 157. And we're going to not rationalize it this time. Since they didn't, which I'm very confused, I'm going to be clear on any assessment I give you to rationalize things because I've taught you how. You should be able to do it. Cosine of Q is adjacent over hypotenuse, which is 11 over 157. And then tangent of Q is opposite over adjacent, 6 over 11. Okay, last problem. Explain how you were able to determine sine, cosine, and tangent of angle Q in exercise 8. Well, it wasn't that bad. I drew a triangle and labeled it using the known ratios. You could have also used the table and labeled, and labeled things like opposite, adjacent, and hypotenuse to help. But I liked the drawing a picture because that's how my mind works. I like to draw pictures. And that's it. I don't know why the slide's here. Good job. We'll do the problem set tomorrow. Nice.